If needs be, we will also attach the ground screw to the grounding terminals. Now, an important thing to understand how to do when you're dealing with circuits, especially lighting circuits, is to be able to calculate current. For example, if you're given two 40-watt lamps, and these two 40-watt lamps are connected to a 110 voltage supply, how do you calculate the total current drawn when both lamps are lit? To do this, you must remember a formula. And that formula, as you can see displayed here, is the Ohm's law power triangle. Now, based on this question, we are given 2 times 40 watts lamps. So we are given two 40-watt lamps, and we know that power is measured in watt. Power is measured in the unit watt. And so the total power that these two lamps will give would be 2 times 40, which is 80 watts. So we understand that. Now, what else? So that would mean that power P is now equal to, and I could open brackets, and that will give me what that is equal to. All right. My power in the circuit is 80 watts. Now, reading the question, I also understand that this circuit is connected to a 110 voltage supply. Knowing that E, which represents voltage, voltage is given in volts. So my voltage is 110 volts. I need to find I. I is current. Using the pi triangle here, if I should cover I would be equal to P over E. As we can see here, P over E, which means power divided by voltage. So substituting my values for the letter symbols, it would be 80 divided by 110. Doing this quick calculation, I would get 0.727 amperes. I oftentimes recommend to students not to round beyond the second or third decimal place, because even small amount of currents can be dangerous. And as we look at different units of currents, we will understand why it's very important to be careful how you round values off. So here we have it. If we have two 40-watt lamps connected to a 110 volt supply, the amount of current dissipated when both lamps are lit would be 0.727 amperes. What if I wanted to know how much current is dissipated when only one lamp is lit? For that, that's a simple challenge for you to do. But all I would do is take away one of the lamps and leave it at 40 watts. The voltage would not change, so it would be 40 watts divided by 110, and that would give you whatever value that is. So you can work that out for yourself. So now you're more equipped. We can move on. Now you have an activity to do. I want you to pause the video having listened to this instruction. Get your coloring pencils, and as you can see at the bottom here, I would have given you the color code. For the black wires, you're going to use, or the hot wires, you're going to use black. For the red wires, you're going to use, that's your switch feed, you're going to use red. For your neutral or white wire, you're going to use brown. And in this case, you can connect the green. You have two circuits, circuit A and circuit B. You are to use your coloring pencils to show the wiring diagrams for the following circuit. So I advise you to pause the video, and you are going to sketch these diagrams very neatly, and then use your coloring pencils to draw the wiring diagrams for these circuits. In circuit A, the source is at the switch, and in this circuit, you will be required to use all three wires. So I advise you to send your green wire as well from the source. Here on the switch is your grounding terminal. That's the only place you will need it. Okay? And consult the other diagrams within the video to understand how to complete the wiring diagram for circuit A. Then, having completed that, you recognize that you still have a source voltage of 110. In fact, for both circuits, use that along with the power value to calculate the amount of current dissipated when this lamp is lit in circuit A. For circuit B, it's the same thing, but the source is actually at the lamp. But notice now you have two lamps. So a key to answering this question is, whenever you get the switch feed coming off the switch, you must share it or splice it between both lamps, just as how you will share and splice the neutral between both lamps. At the end of that, very neatly done, you're expected to calculate the current drawn when both lamps are lit. So I'm looking forward to some great feedback from you after you have completed this activity. Now it's time to recap. What did we learn in today's lesson? The single pole switch is the most commonly used switch. It is the most commonly used control device in electrical installation. It is connected in the hot conductor or the hot line, which is black or red. It is used in 110 volt circuits, a maximum of 125 volts. So anywhere between 110 to 125 volts circuits, the single pole switch is used. And it controls devices or a single device from only one location. There are different variations of the single pole switch, however, all have the same principle of operation. When determining the amount of current dissipated when lamps are lit, Ohm's law must be used. So you must keep in mind the Ohm's law, power and voltage triangles. The color code for wiring diagrams are as follows. Black is for hot, red is for switch feed, white is for neutral, which is also brown, green is for ground, and though we did not